We really can take two very different routes with this problem. The first route would be to write this as a radical. You know, when I say y to the 4/3, how do you rewrite that? The cube root of y to the 4th. And then we would have y to the 5, or y to the 2/3 would be the cube root of y squared. But then it's one of those problems where you have multiple radicals, so we have to isolate one at a time and raise it to a power. And so we could approach it with that path. They would have to be multiplied in order for you to be able to combine them. With adding and subtracting, they have to be like terms. There is an easier way for this if you recognize it. Y to the 4/3, y to the 2/3. Do you recognize anything about those? They have the same denominator, and their numerator one is twice the other. So if I gave you like x squared minus 5x plus 6, you would do box method, right? And we've seen where you could do that with x to the 4th minus 5x squared plus 6. If you have a power, if the middle term is half that and then a constant, it's like a quadratic. Is 2/3 half of 4/3? Yes. So we could really treat this like a quadratic and do box method. Because this is a coefficient of 1, we could do the shortcut. Okay, we just have to divide this in half. So 4/3 divided by 2 is 2/3. So that's y to the 2/3. Then what multiplies to 6 and adds to -5? They have to be the same sign to multiply to a positive. Yeah. For whatever reason, this is the problem that everybody always factors wrong. We had it on a test, I think, and a lot of people factored it into 1 and 6 instead of the 2 and 3. Okay, so then if we set each of these equal to 0, add over 3. I'm going to rewrite this. That means the cube root of y squared. So how would you get rid of a cube root? Cube each side. So 3 to the 3rd is 27. Then how do you get rid of a square? Square root. With that, you always do plus and minus. Okay, how can I break up 27? So 3 radical 3. Okay, this one. Cube each side. So y squared equals 2 to the 3rd, 8. Square root, plus and minus. We could break 8 up into 4 and 2. So we get plus and minus 3 radical 3, plus and minus 2 radical 2. Okay. Good practice. I told you to always check on these. This one we technically don't have to check because we broke it down like a quadratic instead of just starting off by squaring each side of the equation. But certainly, if you're in doubt, check it. You have a calculator right in front of you. It's not that hard just to plug it all in and see if it works. Questions on this? Let's look at this one. You could, if you don't like the negative exponent, we could rewrite it to have a positive one. How would you rewrite 15x to the negative 2? What's a negative exponent do? Brings it down. So 19x to the negative 1 would be 19 over x. Now what?
Put the 6 over 1. We're going to try to do it.
Okay. You're trying to say get a common denominator, I think, which will get us there. Cheryl's idea is, I think, multiply and get rid of the fraction altogether. So we could go either route. Do you guys want to just get rid of the fraction? So what would it take to cancel this x squared? X squared. We had these on the last test, and we said you had to multiply everything by it. And let's see if we need to multiply by anything else. That would cancel this denominator. 19 over x, that would cancel one of my x's. And now, we don't have any fractions left. So we have 15 plus 19x plus 6x squared equals 0.
And now, can you flip it and just do box method?
You can. Can I do the shortcut this time? No. Okay, so those multiply to 90 and add to 19. Factor, we can take out 2x and a 3. 3x and 5. Okay, so if we set those equal to 0, we get a negative 3 over 2 and negative 5. Again, these should work, but why don't we check them, just for fun. Use your calculator, that's the easiest option. So I have 15, parenthesis, negative 3 over 2, close my parenthesis to the negative 2 power, plus 19 times negative 3 over 2 to the negative 1. Plus 6. And does that one work? Yep. Now put in your negative 5 over 3. And you guys know if you have it all typed in, you can just hit second enter and bring it back and then change your negative 3 halves to a negative 5/3. And that one also is 0. So they both work. Always remember to check on these because you can get answers that don't work. Let's look at this one. What would we do here? In order for them to be like terms, the exponents on the variables have to be the same. Keep in mind, if you struggle with the radicals, you could think of this as like an x to the 1/2 minus a 3x to the 1/4. So they're not technically like terms because their exponents are different. But what could we do if we have a 1/2 and a 1/4? We can do the box method here. Okay, x to the 1/2, half of that is 1/4. Multiply negative 4, add to negative 3. Mhm. Okay, so set those equal to 0. If you prefer, you can write it as a radical, whatever you like. The fourth root of x equals 4. So I need to take each side to the fourth power. And 4 to the fourth is 256. Over here I get the fourth root of x equals -1. So if I take each side to the fourth, I get x equals 1. What should we do? Plug them in. Let's check this. Okay, so square root of 256, or you could do 256 to the 1/2 if you prefer, minus 3 times the fourth root of 256 minus 4. And that equals 0. If you put in a 1, does the 1 work?
No.
No, it does not. So 256 is our answer. Any questions? I need to give you guys a problem I want you to do. Here's yours. When I see a 1/4 power, that is the same as a fourth root. So how do you get rid of a fourth root? Take each side to the fourth power. So you get x to the fourth equals 10x squared minus 24. Bring everything over. So x to the fourth breaks into x squared. Multiply to positive 24 and add to -10. -4 and -6. Set those equal to 0. You have to add a square root, which means plus and minus. Okay, so then to check these, you can use your calculator if you want. You just do your parentheses 10 times 2 squared minus 24 to the 1/4. And do we get 2 back out? Yeah. What about when you put in a -2? So if you do 10 times -2 squared minus 24, do you get -2 out? No. So positive 2 works. Now you check your radicals. So 10 times the square root of 6 squared minus 24 to the 1/4. It gives you a decimal. Type in the square root of 6. Are they equivalent decimals? Yeah, so radical 6 works. What if you put in a negative radical 6? Do you get a negative decimal out? No. So only the 2 positive answers work. And we talked how a lot of times when you're checking, the things that won't work will be the negatives. Okay. So that was kind of a review from Friday. Let's do 1 or 2 more and then I'm done. These problems are slightly different. It's going to look a little bit uglier. So my first thing, I'm giving you this beautiful equation, and I want you to write it without a negative exponent. So we're just going to clean this up. Okay. What I am going to do first, the numerator here has two terms. I am going to factor out any greatest common factors. Okay, if you look, this one has a 2/3, but the other one doesn't have any coefficient. This has an x plus 1, but the other one doesn't. But what they both have is x to a power. When you factor, you always take out the smallest power. What's smaller, negative 1/3 or positive 2/3? Negative 1/3. So I'm going to pull out x to the negative 1/3. I take that out, I have a 2/3, x plus 1. I took out my x to the negative 1/3. When you factor it out, it's like subtracting exponents. So what's 2/3 minus negative 1/3? 1. So this just becomes an x. Now that it's multiplied, anything with a negative exponent can go down to the bottom. So I can put this x to the positive 1/3 on the bottom. Do we leave fractions within fractions? No. So we are going to have to do something to get rid of that issue. So if I don't want this 2/3, we want to essentially move the 3 to the bottom, right? But because I have two terms on the top, what I'm going to do is multiply by 3 on the top and bottom.
Wait, why are we multiplying by 3?
To cancel this fraction. So 2/3 times 3 would just be a 2. Minus x times 3 would be a 3x. And then on the bottom we have our 3 times this. We're close here. If I distribute, this becomes 2x plus 2. So combine like terms, 2x minus 3x.
So, does it just go into
Yes, because it's all one term.
and then the negative x?
It's because terms, remember, are separated by addition and subtraction. So this is multiplied together, so that's one term. That's subtracted, so it's a second term. So you have to take the 3 to each term. So I distribute it to this one and to that one.
So, that negative 3x,
Mm-hmm.
how do we get
Because I distributed my 3 to this negative x. So negative x times 3 give me my negative 3x. Other questions?
So you don't take it to the exponents, the 3?
No, we're not cubing. We were multiplying by 3 there. Okay. So if we combine like terms, this would be a 2x plus 2 minus 3x. So 2x minus 3x is negative x plus 2 over 3x to the 1/3 x plus 1 squared. Okay. It's kind kind of ugly, but we did. That was part A. Part B, I'm asking you when this equals 0. So we are going to use our answer to part A to do that. I am just going to set this fraction equal to 0. Now when we were doing this in the last chapter when we were graphing our rational functions. And we said that in these fractions, the very first thing you would do is multiply your denominator over to get rid of the fraction. But what's 0 times anything? 0. So it's really just what makes the top 0. And we get x equals 2. That's our solution. Nice pretty answer for an ugly problem. So there's a lot of algebra involved there. Do you have any questions?
I think
You just want to do another one and see if we can. Let's try one more thing. First, it's a positive 4/3. Okay. We have two terms. This is a term because it's all multiplied together, and this is a second term because they're subtracted. So we start out. What could I pull out of those terms? X to the negative 2/3. You take out your smallest exponent. So if I take that out, I have a 1/3 x squared plus 1. I took out that x minus 2. Okay, when you factor out, you subtract exponents. What's 4/3 minus negative 2/3? 2. Now, what could I do? Negative exponent goes down to the bottom. Our next issue is that we have a fraction on the top. If I wanted to cancel 1/3, what would I multiply by? 3. So I'm going to multiply by 3 on the top and the bottom. Now keep in mind, on the top, I still have 2 terms. So when you multiply by your 3, you have to distribute that to each of the 2 terms. So 1/3 times 3 is just a 1. Minus 2x squared times 3. 2 times 3 is 6x squared. We are one step from our answer. Like terms on the top. 1x squared minus 6x squared. And then your 5x squared. That's our final answer.
So if it's 2/3 on the top and then it's 5/3,
It was a 1/3. Are you talking? Yeah, the exponent was 2/3, so it's a positive 2/3 on the bottom. What other questions? I did 1x squared minus 6x squared, so 1 minus 6. What else? There was another hand over here. So
It was one, but I figured it out.
Part B, I'm asking you to find out when it's 0. So you really just have to think about when your answer from part A is equal to 0. So the first thing you would do is multiply over the denominator, and what happens to it? Cancel, yeah. So I could add over my 5x squared, divide by 5. How do you get rid of the square? Square root, plus and minus. Square root of 1 is 1 over the square root of 5. Can I leave my answer like that? No. Multiply by radical 5 on top and bottom, you get plus and minus radical 5. Do you have a question?
Yeah, I'm doing something like the radical 1 over 5.
Okay, I divided by 5, so I got 1/5. Then this was an x squared, so to get rid of the square, I added a square root on each side. Anything else? I want to give you time to work on your Math Excel so that I can answer individual questions if you're having trouble with something specific. That one is due tomorrow, and tomorrow we will be doing just some more review with this stuff.